Okay, this is section 7.5, and the homework was page 448, 2 to 36 even. I will be doing numbers 1 through 35 odd. Alright, we're rationalizing denominators here. So the reason that we rationalize denominators is because you're never allowed to have a square root in the denominator. So notice here we have the square root of 7 in the denominator. You can never stop doing a problem when there's a square root in, or there's any kind of root in the denominator. You must always get rid of the root in the bottom in order for you to have a final answer. Your final answer can never have any kind of radical in the denominator. So what we're going to do is we're going to rationalize the denominator. In order to rationalize the denominator, all you're going to do is multiply the problem by whatever the denominator is over itself. By multiplying by the square root of 7 over the square root of 7, all we're doing is multiplying the problem by 1. So we're not changing anything. But look what happens when I do that. Because both numerators have the same index of 2, I can multiply them together. So the square root of 2 times the square root of 7 is the square root of 14. And then our denominators, square root of 7 and square root of 7, both also have the same index, so I can multiply those together. The square root of 7 times the square root of 7 is the square root of 49. And if you realize, the reason that we did this is because the square root of 49 is 7. And square root of 14, that is as simple as it can get. So your answer is the square root of 14 over 7. Now that we don't have a radical in the denominator, we're okay to go ahead and finish. And that's our answer. Okay, we're going to do the same thing here, except for we're going to break it up first. We're going to use our quotient rule to say the square root of 1 over the square root of 5. Now remember, you're never allowed to have a radical in the denominator. So what I'm going to do is I'm going to multiply by this square root of 5. And whatever you do to the top, you always have to do to the bottom. So it's square root of 5 over square root of 5. Because the square root of 5 over the square root of 5 is just 1, so again, all I'm doing is multiplying by 1. So we're going to say the square root of 1 times the square root of 5 is the square root of 5. And then the square root of 5 times the square root of 5 is the square root of 25. We can't do anything with the square root of 5 in our numerator, but the square root of 25 is just 5. So our answer is the square root of 5 over 5. Alright, same situation here. I'm going to use my quotient rule to say the square root of 4 over the square root of x. First off, I'm going to simplify. I know the square root of 4 is 2 over the square root of x. Now I need to get rid of this radical in the denominator. So I'm going to multiply by the square root of x over the square root of x. This will help me rationalize my denominator. So I'm going to say 2 times the square root of x is 2 square roots of x. And then the square root of x times the square root of x is the square root of x squared. And remember, a square root and a square cancel each other out, leaving you 2 square roots of x over x. And that's your answer. Okay, here's where it's going to get a little different. If you have anything, if your index is anything other than 2, it gets a little bit different. So what's going to happen is I'm going to multiply by the cube root of 3 over the cube root of 3. But here's the catch. In order for something to cancel out, in order for the cube root of 3 to cancel out, it needs to be the cube root of 3 cubed, right? Because then your cube root and your cubed will cancel each other out, leaving you just 3. But if I just multiply by the cube root of 3, then what's going to happen is I'm going to get 4 cube roots of 3 over the cube root of 3 squared. This index and this exponent don't cancel each other out. I need this to be a 3 in order to be able to cancel the root and the exponent. So what's going to happen is instead of multiplying by cube root of 3 over the cube root of 3, I'm going to say the cube root of 3 squared over the cube root of 3 squared. Okay? So now what happens is I say 4 times the cube root of 3 squared, which is 4 times the cube root of 9, because 3 squared is 9, over the cube root of 3 times 3 squared, which is just going to give you 3 cubed. Now, the cube root and the cube cancel each other out, leaving you 4 cube roots of 9 over 3. And that's your final answer. Okay, so we have a radical in our denominator, so we need to rationalize our denominator. Now, the first thing you need to do is simplify anything that you can. I can simplify this 8. 8 is 4 times 2, and 4 is 2 times 2. Because my index is 2, I need something to repeat twice in order to bring it out front. So this is 1, 2, and then I have a 2 left over and an x left over. So this is going to become 3 over 2 square root of 2x. I brought a 2 out front, and I left a 2 and an x inside. Now that I've got that done, I'm going to multiply by just what's inside the radical. So it's the square root of 2x over the square root of 2x. Okay, you don't need to worry about this coefficient out here. Okay, we'll deal with it later, but you need to multiply by whatever the radical is. So it was the square root of 2x, so it's square root of 2x over the square root of 2x. So now when I multiply these together, I say 3 times the square root of 2x, which is 3 square roots of 2x over 2, that's this 2 right here, times the square root of 2 times 2 is 4, and x times x is x squared. Okay, let's clean this up some. I've got 3 square roots of 2x over the square root of 4 is 2. So I have 2 times, that was my original 2 right here, and then the square root of 4 is 2, and the square root of x squared is just x. So that leaves me with 3 square roots of 2x over 2 times 2 is 4x. Alright, this is one of the trickier ones. Notice I have a cube here, so that means I'm going to need 3 4s in order to cancel it out and 3 x's in order to cancel it out. So I'm going to multiply by the cube root. So I have 1 4 here, and I need 2 more in order to make it 3 4s. So I'm going to say 4 squared. And I have 2 x's here, but I need a third x in order to be able to make it cancel. So I'm going to say x over the cube root of 4 squared x. So let's clean that up a little bit. 3 over cube root of 4x squared times, we know that 4 squared is 16, so we're going to say cube root of 16x over the cube root of 4 squared x. Now, the reason I left that the way that it is you'll see in just a second. So now I multiply numerators. So this becomes 3 times the cube root of 16x all over the cube root. Now I've got 1 4, 2, 3 4s. So 4 cubed. Then I've got 2 x's, 3 x's. So x cubed. Okay? So I've got the cube root, and the cubes cancel, leaving me just 4x in my denominator. And in my numerator, I can break this 16 down a little further. So I've got 3 times, that's this original 3 out here. All right, let's break down the cube root of 16x. 16, we know that x is going to be part of our radical because there's only one of them and I need 3 in order to be able to pull it out front. But 16 can be broken down into 4 and 4 and 2 and 2 and 2 and 2. So 1, 2, 3. So I've got a 2 can come out front, cube root, and I've got 2x left inside. Okay, so now the first thing I'm going to do is multiply these together. 3 times 2 is 6. Cube root of 2x over 4x. Now you think you're done. However, this 6 and this 4 can be reduced. So 6 over 4 becomes 3 over 2 if I divide both by 2, leaving me 3 cube roots of 2x all over 2x. Okay, and this one I'm just going to multiply by the square root of 3a over the square root of 3a. So this becomes 9 times the square root of 3a over the square root of 9a squared. So that gives me 9 square root of 3a over the square root of 9 is 3. Square root of 9 is 3. And the square root of a squared is a. Now you might begin to notice that when you go from this step, the square root of 3a times the square root of 3a, you can immediately go straight from here to here if you want to. The square root of 3a times the square root of 3a is the square root of 9a squared. But when you multiply these together, what happens is you end up with the square root of 3a squared. So the square root and the square cancel. So you'll always just be left with the radicand. So if you can remember that, if you can just take your radicand, that's going to become your denominator, and you can skip this step if you want to. Alright, but be careful. This 9 and this 3 can be reduced. 9 divided by 3 is 3 over 1. So your answer becomes 3 square roots of 3a over a. And that's your final answer. Okay. Here's another one of the trickier ones. We've got the cube root. So in order to make the cube root cancel, I need 3 2's. I have 1, so how many more do I need? I need 2 more. So I'm going to say the cube root of 2 squared over the cube root of 2 squared. I had 1, 2, and I need 3 in order to cancel the index of 3, so I wrote 2 more here. So 3 times the cube root of 2 squared is 3 cube roots of 4, because we know 2 squared is 4. And then you've got the cube root of 2 cubed. Cube root and cube cancel each other, leaving you 3 cube roots of 4 over 2. And that's your final answer. Okay. When rationalizing the denominator, I have a square root of 7. So I need 2 7's because my index is 2. So I'm just going to say the square root of 7 over the square root of 7. So I'm going to have 1 7 here and 1 7 here. So I need 2 7's. So I've got 1, 2 in order to make it work. So I'm going to say 2 cube roots of 3 times the cube root of 7 is 2 cube roots of 21 over the cube root of, or the square root of 7 times the square root of 7 is the square root of 49. So you have 2 square root of 21 over 7 because the square root of 49 is 7. Okay. we need to rationalize the denominator, so I'm going to multiply by the square root of 5y over the square root of 5y. Multiply your numerators. Square root of 2x times the square root of 5y is the square root of 10xy all over the square root of 25y squared. The square root of 10xy, can't do anything with that, but the square root of 25 is 5, and the square root of y squared is y. So that is your final answer. Okay, the first thing we're going to do here is we're going to break this up into the cube root of 3 over the cube root of 5. Now, in order to get my cube root to cancel in my denominator, because my index is 3, I need 3 5s. I have 1 here, so when I go to multiply, I have to multiply by the cube root of 2 5s. So that's 5 squared. Cube root of 5 squared. In order to get it to cancel, I need 3. So I've got 1, 2, 3, because it's squared. So first we're going to multiply our numerators. Cube root of 3 times the cube root of 5 squared. So cube root of 3 times the cube root of 25 over the cube root of 5 cubed. Now the cube root and the cube are going to cancel. And because these both have the same index, I can multiply the radicans together. So this becomes the cube root of 75 over 5. Now 75 seems like an awfully large number. Let's see if we can simplify that at all. So if I have the cube root of 75, 75 is 25 times 3, and 25 is 5 times 5. In order to be able to bring a number out front, I need 3 of them. I don't have 3 of anything, so I can't simplify this at all. So the cube root of 75 over 5 is our final answer. Okay, square root of 3x over 50. First thing I'm going to do is use my quotient rule to say the square root of 3x over the square root of 50. Now I'm going to see if the square root of 50 simplifies at all, just to be safe before I go on. So 50 is 25 times 2. And 25 is 5 times 5. I need 2 in order to be able to bring a number out front. So this becomes 5 square root of 2. And this is still the square root of 3x. So if you have the square root of 3x over 5 square root of 2, when you go to decide what you're going to multiply by, ignore this 5. Remember, all you need to do is multiply by whatever the radical is. So when I go to multiply, I'm going to say the square root of 2 over the square root of 2. Don't worry about that 5 out in front. So the square root of 3x, square root of 3x times the square root of 2 is the square root of 6x over 5 times the square root of 4. Well, the square root of 4 is 2, so this becomes the square root of 6x over 5 times 2, which is just 10. So it's the square root of 6x over 10. Okay. First things first, we need to simplify 12. So that's 4 times 3, and then 4 is 2 times 2. Because my index is 2, I need a repeat of 2 in order to bring a number out front. So this is going to become 1 over 2 square root of 3z. So when I go to figure out what I need to multiply by, ignore the 2. You only want to multiply by the radical. So it's going to be radical 3z over radical 3z. When I go to multiply these together, I say 1 times square root of 3z, which is just the square root of 3z, over 2 times the square root of 3z times 3z is 9z squared. So if I simplify this, I have the square root of 3z over 2 times the square root of 9 is 3, and the square root of z squared is just z. So 2 times 3z. So my answer is the square root of 3z over 6z. Okay, here's another situation when we're dealing with an index that is not a 2. So in order to get this index to cancel, I need 3 9s. I have 1, so I'm going to need 2 more. And I need 3 x's. I have 2, so I'm going to need 1 more. So when I go to multiply, it's going to be the cube root. I need 2 more 9s, so I'm going to say 9 squared. And I need 1 more x. And then it always stays the same in the numerator and denominator. Okay, let's multiply our numerators. So it's the cube root. 2 times 9 squared is, well, 9 squared is 81. 81 times 2 is 162. X, y squared, all over the cube root. I've got 3 9s, 1, 2, 3, of 9 cubed, and I've got 3 x's, 1, 2, 3. So x cubed. So down here, my cubed and my cubes cancel, leaving you just 9x. And in the numerator, you know your x and y squared are going to stay, but is there anything I can break 162 down into? So let's find out. I need the cube root of 162. I know 162 is 81 times 2. And then I know 81 is 9 times 9. And then I know 9 is 3 times 3, and 9 is 3 times 3. I need 3 in order to be able to bring a number out front. Okay? And then anything else stays behind. So that's going to leave me with 3 cube roots of 6x y squared. Anything outside our radical can be reduced, so 3 over 9 becomes 1 over 3. So your final answer is the cube root of 6xy squared all over 3x. Alright, we've got some decently large numbers here with 81. Let's see if we can simplify this at all before we do anything. So if I have the fourth root of 81, 81 is 9 times 9. 9 is 3 times 3. So I need 4 in order to bring a number out front. So the fourth root of 81 is just 3. That is going to make our life a heck of a lot easier later, leaving me the fourth root of 8 in the denominator. Because my index is 4, I need 4 8s in order for the fourth root to go away. I have 1 8, so I need 3 more. So I'm going to multiply by the fourth. So I'm going to multiply by the fourth root of 8 cubed over the fourth root of 8 cubed. Okay, so when I multiply the numerators together, I get 3 times the fourth root of 8 cubed over the fourth root of 8 to the fourth. The fourth root and the 4 cancel each other, leaving me 3 times the fourth root of 8 times 3, which is what? 64 times 8, which is 32. 512. The fourth root of 512 over 8. I'm going to go ahead and go out on a limb here and say that we can probably reduce 512. So I've got the fourth root of 512. What times what gives me 512? Well, I just showed over here that 64 and 8 give me 512. 64 is 8 times 8. And 8 can be broken down to 4 and 2. And 4 can be broken down to 2 and 2. These are one of the problems where it's really important to cross things out as you go. So I need 4 in order to pull one out front. So I've got 1, 2, 3, 4. That's 1 I'm going to pull out front. 1, 2, 3, 4. That's 2 I'm going to pull out front. And I've got a 2 left. So the fourth root of 512 is 4 roots of 2. And remember, I got 1, 2, 3, 4. That was 1, 2. And 1, 2, 3, 4. So I brought 2 2's out front, and 2 times 2 is 4. Now, I had 3 times the fourth root of 512. And we changed the fourth root of 512 to 4 fourth root of 2. And this was all over 8. 3 times 4 is 12. So that's 12 fourth root of 2 over 8. 12 over 8 can be reduced to 3 over 2. So it's 3 fourth root of 2 over 2. And that is your final answer. Okay, before we get started on this one, let's go ahead and simplify. The fourth root of 16 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And then I've got the fourth root of 9, which I can't do anything with. But the fourth root of x to the 7th, if I bring my index back and make it my denominator, 4 goes into 7 one time, which means I can bring an x out front. And then there's 3 left over, which leaves me x cubed left. So now I've got 2 over x times the fourth root of 9x cubed. Now, in order to get this fourth root to cancel, I need 4 9s and I need 4 x's. Don't worry about this x right here. So when I go to multiply, I need 4 9s. I have 1. I need 4, and I have 1 here. So when I go to multiply, I know I'm going to multiply by the fourth root of 9 cubed over the fourth root of 9 cubed. And then now we need to take care of the x's. I have 3 x's. I need 4 in order for it to cancel. So I just need 1 x here and 1 x here. Okay? So if I multiply the numerators, I get 2 times the fourth root of 9 cubed x over x, because don't forget about this x right here, fourth root of 9 to the fourth, x to the fourth. So this 4 and these cancel, and you have 2 times the fourth root of 9 cubed x all over x times 9 times x, which is 9x squared. Now, we need to clean this up. We're not going to leave it 9 cubed. So 9 cubed is, 9 times 9 is 81, and 81 times 9 is 729. So I've got 2 times the fourth root of 729x over 9x squared. So let's see what the fourth root of 729 can do for us. 729, as I just showed over here, can be broken down into 81 and 9. 9 can be broken down to 3 and 3. 81 can be broken down to 9 and 9. And the 9s can be broken down to 3 and 3. Now, because my index is 4, I need a number to repeat 4 times in order for me to be able to bring it out front. So 1, 2, 3, 4. I can bring 1 3 out front, and I have 2 3s left behind. So don't forget about this 2 right here, okay? So I have 2 times. I'm going to bring a 3 out front because of those 4 3s. And then I have the 4th root of, I'm left with 2 3s on the inside and an x. So 3 times 3 is 9x over 9x squared. So I'm going to multiply this 2 and this 3, leaving me 6 times the 4th root of 9x over 9x squared. And then this 6 and this 9 can be reduced to 2 over 3, which gives me 2 times the 4th root of 9x over 3x squared. Last one. Let's simplify first. 5th root of 8 we can't do anything with. 5th root of a to the 9th. So let's go ahead and split this up a little bit so you're looking at it as separate pieces. The 5th root of 8, can't do anything with that. The 5th root of a to the 9th, that's a 9. And then the 5th root of b to the 11th. Let's see what we can do with these. 5a, we're just going to leave that alone. 5th root of 8, can't do anything with that. 5th root of a to the 9th, if we bring our index back and make it our denominator, 5 goes into 9 one time, which means that we can bring an a out front. Okay, and then there's 4 left over. So that leaves me with a to the 4th under the radical. Then we can take our index back here and make it our denominator. 5 goes into 11 2 times, which tells me that I can bring 2 b's out front. So that's b squared. And then if I bring 2 b's out front, that gives me 10, and then I just have 1 left over. So then I put a b here. Okay, so just to clear that up, I have 5a over ab squared times the 5th root of 8 a to the 4th b. Now at this point, you can go ahead and cancel these a's to make your life a little bit easier, leaving you 5 over b squared times the 5th root of 8 a to the 4th b. Now remember, in order to get this 5th root to go away, I need 5 8s, 5 a's, and 5 b's. So when I multiply, I'm going to multiply by the 5th root of something. I need 4 more 8s, so 8 to the 4th. I need 1 more a, and I need 4 more b's. And remember, whatever you do to the numerator, you must also do to the denominator. So a to the 4th, a, b to the 4th. Okay, when I multiply the numerators, When I multiply the numerators here, I get 5 times the 5th root of 8 to the 4th a b to the 4th over b squared times the 5th root of 8 to the 5th a to the 5th b to the 5th. So this 5th root cancels this 5, and this 5. So I have 5 times the 5th root of 8 to the 4th, a, b to the 4th, all over b squared times 8 times a times b. So that's just 8ab cubed. All right. Let's see if we can clean this up at all. Okay, so let's see if we can break this up. The fifth root of 8 to the fourth, which I have no idea what that is. So 8 times 8 is 64. Times 8 is 32, 48, 51. So 512 times 8 is 16, 9, and 4,096. Okay? So when I break this down, I know that it is 512 times 8, and I know that 512 is 64 times 8. 8 is 4 times 2, and 4 is 2 times 2. 8 is 4 times 2, and 4 is 2 times 2. Okay, 64 is 8 times 8. 8 is 4 times 2. 4 is 2 times 2. 8 is 4 times 2. And 4 is 2 times 2. Okay, so I need 5 in order to bring it out front. 1, 2, 3, 4, 5. That's 1. 1, 2, 3, 4, 5. That's 2. And then I'm left with 2 left behind. So if I can bring 2 2's out front, that's 4 times the fifth root. And I had 2 2's left behind, so it's just 4. And then going back up to our problem, here we have an a b to the fourth, and we have a 5 out front. So we've got a 5 out front, and then I said we had a, what was it? A b to the fourth. All over 8ab cubed. Okay, so let's clean it up. 5 times 4 is 20. 20 times the fifth root of 4 a b to the fourth, all over 8 a b cubed. 20 and 8 can both be reduced by 4, leaving me 5 over 2. That's weird. We'll just go with it. So we're going to, oh my god, look. Crazy. Anyway. Okay, so you're left with 5 times the fifth root of 4ab to the fourth, all over 2ab cubed. And that is your final answer.